So when a function has a repeating x-intercept, that's what our examples here on are going to focus on. We say that that root or x-intercept or 0 has a multiplicity of 2. Okay, so because it repeats twice, we call it a multiplicity of 2. The behavior of a graph at a root depends on its multiplicity. If a root has what's called an odd multiplicity, the graph will cross through the x-axis at that root. If the root has an even multiplicity, the graph will not cross the x-axis at that root. It just sits on it. Okay, so we're talking about repeating x-intercepts. It's called multiplicity. If it repeats an even amount of times, it will not cross. If it repeats an odd amount of times, it will cross. So let me show you with the diagram what I mean. So this we call an even multiplicity because the exponent is even. Shockingly, we call this an odd multiplicity because the exponent is. Now you've actually seen both these graphs before. This is a parabola and this is a cubic. Tell me about this parabola. Where's the vertex? 1 and 0. And you know it is pointing up. So what happens with this one is it just sits on the x-axis. It doesn't cross through the x-axis. It just sits there. That's because it has what we call an even multiplicity. It just bumps the x-axis and goes back up. This one is our base cubic with a horizontal translation 1 unit to the right. So we get our snaky guy that goes through 1. That's called an odd multiplicity, which means it crosses through the x-axis. Okay, definition so far in multiplicity. Okay, so let's look at example 4 and we'll see how this is going to change how we graph this. Step 1. Very first step. It's in a box. We put a highlighter around it. Name it. So when it's already in factored form, we just need to multiply all the x's together to see what the degree is going to be. So x times x times x is a degree of 3. Okay, so name it. Cubic. Does it have a positive leading coefficient or a negative leading coefficient? Okay, so you can either go to your chart, or if you've already got this memorized, you're looking for odd polynomial, positive leading coefficient. Tell me about the end behavior. Down and up. Tell me about the number of max mins. 2. Again, you're not required to write any of that down. If you want to, great, but you don't have to. X-intercepts. And what always gets me is people like get this form and they freak. They're like, what do I do? What do I do? I'm like, but it's already factored. So we actually like when they give us this form because we can go right to the split and solve. The first binomial, x is going to equal. And the 2 binomials remaining are exactly the same. X is going to equal 3. This we would say has a multiplicity of 1, where this guy has a multiplicity of 2. That means that it's going to cross through the first one, which is what it usually does at x-intercepts. But what's going to happen at 3? It's just going to sit on the x-axis. It's not going to actually cross through. That's how we use the multiplicities. Okay, so a normal x-intercept has a multiplicity of 1. I lost my stickies. Found my stickies. If it's got an odd exponent, it's going to cross. If it's got an even, it's going to sit. Y-intercept. Again, people freak when they're given factor form. I don't know how to do this. Do it the same way we always do it. How do we calculate an x-intercept? Okay, so we're just going to put in 0 everywhere we see an x. And we had an offer of 9. Okay, let's grab our sticky. So x-intercept at -1, x-intercept at 3, 0, 9. Tell me what's going to happen at the left. Tell me what's happening at the right. Tell me at the first x-intercept, does it cross or does it sit? So I'm going to actually just show it crossing. What happens at the right intercept? So I'm just going to show it bouncing back up. So it's just sitting, it's not crossing. So we know it has to go through the y-intercept, and we know it has to go through those x-intercept. We know it crosses on the left, and it just sits on the right. What do I not know at this point? So what am I missing so far in this? I know the min's here. This has to be the min, because our min is here. It's the max. I don't know specifically what's happening in here. Well, what's halfway between these two intercepts? Offer of 1. Okay, so what do I need to do? Test point at 1. Thank you. Offer of 8. Confirm. Does that give us enough to finish our graph? Okay, so it comes from the left, goes up through 9, down through 8, comes down, bounces off the x-axis, and points back up. Just to review, why does it not cross at the second x-intercept? Because there's a multiplicity of 2, which is an even multiplicity. We went halfway between the intercepts, just like we did on the other examples. So exactly halfway. Okay, go to the bottom of our little right brain chart here. So these are basically the various situations you're going to run into. So they each have a multiplicity of 1. One of them has a multiplicity of 2. The other one has a multiplicity of 2. They both have a multiplicity of 2. Okay, so if we were to just solve this, x would equal a and b. And that means they're both positive values. So they're both on the right side of the x-axis. What kind of polynomial is this? Sorry? It is a parabola. How do we know it's a parabola? Because it's going to be x squared. Does it have a positive leading coefficient or a negative leading coefficient? So we know this is going to point up. How do I know it's crossing through both of those x-intercepts? It's not even, it's odd, right? It's a normal x-intercept. It's got a multiplicity of 1, which we've never talked about because it just means it crosses through. Okay, what's going to happen with this guy? Well, if we split and solve, x is going to equal and positive b. So that means one x-intercept is on the left and one x-intercept is on the right. What kind of polynomial is it? How do we know it's a cubic? So this would give us x squared, and times a third x would give us x cubed. Positive or negative leading coefficient? Positive, so it's going to start down and then finish up. Does it cross through minus a? Okay, how do we know it crosses through? Because it's odd. It's going to have some kind of max. What's going to happen at b? It's going to bounce back up. Why does it not cross through b? because the multiplicity is even. Is this starting to make a little bit of sense? Okay, third scenario, x equals. So exactly the same answers as before, and that just means one's on the left and one's on the right. What kind of polynomial? Still cubic, because it's the exact same equation as here. End behavior? Okay, so it's going to go down and it's going to go up. What's the difference between these two? Multiplicity. So it's going to bounce back down at A, but it's going to cross at B. Okay, so there's the difference if we switch where that exponent of 2 is. Am I going too fast? Okay. Last one, x equals. And, okay, so same situation, one's on the left, one's on the right. What kind of polynomial? Quartic. How do we know it's a quartic? 2 squared, so x squared and x squared, multiply them together, x to the 4th. Positive or negative leading coefficient. Okay, so look up on your chart. You're going for even exponent, positive coefficient. Okay, so we know it goes up on this side and up on that side. Does it cross through A or just sit on A? How do we know? Even multiplicity. And is it going to sit on B or cross through B? Sit on B, and there's where our W comes from. Does the multiplicity make sense? Our last one, I think it's our last one. Our last one. You tell me what to write down. I will write down whatever you want me to. Not whatever you want me to, I should specify. So as a class, walk me through it. You have your steps in the box, the same as before. And I'm just going to put number just so we don't think that's a value. So the number of maximums is 3. Let me know if you disagree with anything, because I'm just writing down what you're telling me to. I agree. Nothing else you want to write down before the graph? Hint, hint, hint. I think we did that first. Heard an offer of 9. Okie doke. Now what? Someday I'm going to give you a method box like you give me. We'll just draw it with no steps. Okay, well, what do we know so far about these points? Let's talk about the x-intercepts. We might. What do we know about the multiplicity? Okay, so it just sits. And this one? Sits. Okay. And behavior we know, so we know it's going up and it's sitting there, and we know on this side it's going up and sitting there. What does it have to do in between? And then? Do we need a test point?
Yes.
We could. The exam will give you full marks for doing that. So the mark breakdown is typically 1 mark for having the correct x-intercepts, 1 mark for having the correct multiplicity, meaning it's sitting, not crossing, a half mark for the correct y-intercept, and a half mark for the correct shape, meaning the 2 endpoints point up and it's a quartic. If you wanted to do the exact max and do a test point, great, but you wouldn't need to on the exam. As long as you can get the general shape, good to go. These aren't bad, eh? Compared to rational graphs, these are fairly easy.